Hey everyone, welcome back. In the last video, we developed a simple Spring Boot application and then we deployed it onto the local Kubernetes cluster. And that application had no dependency. So in this video, what we will do, we will add the database dependency, and for that we will use Postgres. So we will build on the same concepts. We will still develop a Spring Boot application that will have the database dependency. It will use Postgres as the database. And then we will use this combination to deploy the application onto the Kubernetes cluster, which is the local Kubernetes cluster. So without wasting more time, let's dive in. So before we write any code, let's understand what we are going to build. First of all, we will build the Spring Boot app. So say this is the Spring Boot app, and this Spring Boot app needs to talk to a database. So we need a database running. There are many ways to install the database on your local system, but in this case, we are going to run the database in a Docker container. So suppose this is the Docker container, and in this Docker container, we will start the Postgres database, and the app will talk to this database using the Docker container. To do that, we will also expose the same port from the Docker container to the host system, which is 5432, so that the application can connect to the database running on 5432. Because by default, ports are not open, so anything that is running outside the Docker container cannot access the application. So we need to open the port. The other thing that we will do, so the containers are ephemeral. That means from the same image, if you run a new container, the data will be lost. Anything that was stored in the Docker container is lost. But databases needs to persist the data. So to do that, we will also use something called volume mount. In that case, what we will do, from my Windows machine, I will use a folder. I will use this folder as a volume mount. So when we run the Docker container, when we run the database, and let's say we are inserting some data, so that data will be stored in the database, but underlying storage will be this folder, because databases needs to persist the data in the files. So this folder will act as a backup. In that case, what will happen, say this container crashes and I start a new container with the Postgres database. And if I use the same volume mount, so in that case, this new Docker container will access the same data from the volume mount. So this is just to make sure that we persist the data and we do not lose the data while running the database in a Docker container. So two things. First, we are going to build this Spring Boot app. Then we are going to run Postgres in the Docker container with volume mount. So let's get started. So the first thing is to have the Spring Boot application, and we have done it many times. So you can go to the Spring Initializer, add the required dependencies and create one. As for the dependencies, you can see we are using Actuator, we are using Starter Web, Data JPA, Lombok, and the Postgres driver, because Postgres is the database that we will use. Going to the application.properties, you can see that we are enabling the health endpoints by Actuator, so that the same can be used by Kubernetes when we deploy the application as health props. Then we have the database properties, and you can see that we are accepting the database properties using VM arguments or environment variables, but there is default value. So if we do not provide anything, this is the database that we will connect to. So this could be your local database or dev database. In this case, this is running on my local machine, exposing 5432, which is the default Postgres port, and this is the name of the database. But using these variables, we can override the connection properties. And if you notice, in this case, we are setting ddl-auto as none. That means when we run this application will not create the database. So usually in demo applications, we put all the dependencies in the database. So when we run the application, Hibernate automatically creates the tables and everything. But in an actual application, database already exists and your application is just connecting to the database. So in this case, when we run the Postgres in a Docker container, we will use something called init scripts to initialize the database to get it in a desired state, so that application can talk to the database directly without worrying about the tables and everything. But in this demo, app will not perform any DDLs, any queries. That means the table creation or database creation queries. Alright, so that is why the ddl-auto is none. It assumes that the database is already up and running and the application will just need to connect to the database. So if we check out the remaining bits, then you can see I have put everything under the same class. So we are not creating different packages and different classes in different packages. So you can see we have an event controller that is exposing an endpoint events. Okay, so this is using event repository that we will check in a second. There are two endpoints, one get that will return all the data using the repository, then one post endpoint that will simply add a new event to the database. Then we are mapping the incoming request to the JPA entity, and you can see this is a very simple mapper. and in an actual application we will use something else. So this is the record that will map the incoming request to this particular record, post event request, that we are using in the request body. Okay. As for the JPA entity, this is the JPA entity that represents an event in the database. So it has the primary key ID, title, description, venue, start time, end time, total sales, and price. So there are various attributes of this JPA entity. So these all properties will be the columns of the new table, and the name of the table is events. As for the repository, this is a plain JPA repository, nothing special in that. All right. So this is all we need for this demo. If we start this application, because the code is already there, then we should be able to access the events endpoint. So the service is up. Let's try to access the events endpoint. To do that, we'll go to the Chrome in this case. And if we just reload this page, then we get an error. And if we check out the logs, then we see there are errors related to the database because there is no database running on my local system. So we need to run the database. To do that, we need to find the Postgres image. So you can go to the Docker Hub page, the Docker registry, where you will find all the images, and this is the Postgres image. So we will use this image to run a Docker container on my local system. There are few things that we need to provide when we are running the Docker container. The first one is some environment variables. So the first one is Postgres user. Then you also need to provide Postgres password. And to initialize the database while running the container, okay, by using some init SQLs, we need to mount one more volume, that is docker entry point initdb.d. So this must be the same name, exactly the same name, and whatever scripts or SQL scripts we provide, we need to bind them so that when the Docker is starting the container for the Postgres, it will find the scripts in that folder and it will run the queries or whatever we have written in those scripts. So for the demo, in the folder where I have the project, I have also created init.sql. So when the Docker container is running while initializing the Postgres, I will mount this directory, this file. So when it starts the container, it will run anything that I have written in this SQL file that will initialize the database. So if I show you this file, this simply says that if you do not find the database demo.db, then create the database. Then in that database, create the events table with all these columns. And then this is creating some indexes, which we can ignore. But it is also inserting some dummy records in this table. So this sort of thing we can do using initialization scripts. So this file that I have created, it is in the same folder parallel to my project. So this is my Java code, Spring Boot app. And in parallel, I have created this init.sql. Then we have another folder pg-local, which is empty right now. This folder will act as the volume mount so that Postgres can persist the data in this directory as a backup. This will act as a backup for us, but this is simply an attached storage to the Docker container where it can store the files outside the container. Then we also have an infra folder in which I have some YAML files which we will use when we deploy the application on the Kubernetes. Okay, so as of now, we need to basically use this init.sql and pg-local when we start the Docker container. So to start the Docker container, I will use Docker desktop. So let's go to the Docker desktop. And here I already have the image Postgres tag 17.6. If you do not have it already, just download it from the Docker Hub registry, or you can search it here as well. So if I just search it here, Postgres, then you can see I will have all the Postgres images. So I can download the image from here as well. So you can pull the image or you can run it directly. Since I have the image already, so I will start a new container and then I will provide all these settings. So name of the container. Then we need to bind the host port from my local machine to 5432 running inside the container. And this is how we mount the volumes. So the first thing is you need to bind the folder that is on the host path or on your local machine. So as I said, I will use pg-local. So this is the folder that I will use as the volume mount. And inside the container, the path that we need to give is var-lib postgres-sql. Let me double check. So if we go to and you can see this is the path, var-lib postgres-sql-data. Okay. Then we also need to mount another volume that is for init scripts. And in my case, the init.sql is in this folder, and inside the container that must be the thing that we saw. So let me just find it. This one. And in my case, the name of the script is init.sql. All right. Then we also need to pass the environment variables. So we saw the environment variables here. So the first one is Postgres user. And I will keep it Postgres. And in the same way, we need to pass Postgres password. And that's it. Let's start the container. So we can see the container is up and running, server started, but there is an error that it could not read the input file, basically the init.sql that we mount as a volume. And I think the problem is if we check the bind mounts, then we can see that for the init.sql, we forgot to add the init.sql file from the host machine. So this is basically treating the whole folder and could not find any script. Okay. So let me correct this. So I have deleted the old container and started a new one by correcting the volumes. And this time you can see that it found the init SQL and it created the database. Basically, it ran all the queries. It also created the index and there were insert. So you can see the server is up and running and it is ready to accept the connections. So let's verify if we have the data in the table. To do that, we can use a Docker desktop in this case as well. We can go to the exec tab, or you can exec to the container using terminal. So in this case, what we will do, we will first log in the database. And then we will connect to the database that we created, DemoDB. And if we check the tables, then we have the events table. And if we check the data, then we have the 3 records which were there in the init.sql. So the database is also up and running. So let's go back to the local application and restart the application. So the service is up and this time there should be no DB exceptions. So, but we see password authentication failure for user Postgres. We are correctly connecting to the Postgres using Postgres and this is running on the local. Why is it failing with password authentication? Okay, so after some debugging, I found out that there are two Postgres processes running on my local machine listening to the same port. One was the Docker container and the other one was the native Postgres that I installed on my local. So that is why the request is reaching to the Postgres installation, native Postgres, and that does not have the Postgres user. That is why the authentication failure. So you can run the same commands in case you are using Windows and you end up with the same problem. So this is the one that we check the number of services which are listening on the same port. So you can see there are 2 services by PID 9676 and 9056. So there are 2 services listening on the same port 5432. And if we check the process related to that process ID, then we can see this is the Docker container that we are interested in. And this is the Postgres installation on my local. So what I had to do, I had to kill this service like this, stop service, and the name of the service in this case was this one. And after killing the service, if I check the ports again using the same command, then I can see there is only one process which is now listening on 5432. So this time this should work. Let's restart the service. So the service is up and this time there are no DB exceptions. So this means the connection was successful. In that case, since the database is already up and running, so we can go to the events endpoint and we can see the data. And that is because we already inserted some dummy data while initializing the Docker container using init.sql. The important thing is we are running the database in a Docker container on our local machine and the application is connecting to the database and fetching the records correctly. So that means the connectivity and the setup is working fine. Now that we have made it work, we have the application connecting to the database running in a Docker container. In the next step, we will deploy it on the Kubernetes. So let's understand how to deploy this application on Kubernetes. Let's spend some time on this diagram and try to understand different objects, different Kubernetes objects that we will create. So first of all, to run the application, we need a container image of the Spring Boot app that we created. So this is the application image. Then when we run the application image inside the Kubernetes, what we actually run is a pod. So this represents the application pod. And on top of this application pod will be the deployment, which is Kubernetes deployment. And then we will expose a Kubernetes service, So that represents the app service. And in this demo, this will again be a cluster IP service. That means only accessible within the Kubernetes network. Okay. Then to run the database, we will have another pod, which is the DB pod. And in this DB pod, we will run the Postgres image. So we will have a running Postgres database in this DB pod. And in the same way, there will be a DB service. And all these objects are Kubernetes objects. So when I say service, this is a Kubernetes service. When I say pod, this is a Kubernetes pod. Okay. Now to run the database, we will create something called stateful set. Stateful set is another Kubernetes object that provides some guarantees related to the pods. So we will understand stateful set in a second. In addition to application service and DB service, we will also use config maps and secrets. These are again Kubernetes objects, and these will be used to inject some properties, some environment variables to both the pods. Then we will also create a custom namespace. A namespace is like a resource group that will be used to put together all the resources that we will create under this namespace. Okay, so they can be grouped, they can be handled and managed together. And all these objects will be created on the Kubernetes, which is running on my system using Docker Desktop. And so we have the local system, which is the outer box. Okay. Now, in order to test this, we know the application service will expose the port 8080. Database, in this case, Postgres, will expose 5432. Within the Kubernetes network, the app service can talk to the DB service. That means the application can connect to the Postgres using port 5432. But how do we test this application? So in the last video, we talked about the port forward thing. So what would happen on my local system? We may have a client, in this case, for example, Chrome, and using Chrome, using browser, we can hit the endpoint localhost :8080 and the endpoint. So using port forward, what will happen? The call will be redirected from the 8080 port, which is on my local system, which is the Windows machine, to the 8080 port, which is exposed in the Kubernetes. So that is the job of port forward. So when we run the port forward, we can test the application by accessing the app service on the 8080 port. But under the hood, what is happening? There is a link between this 8080 and this 8080, which is within the Kubernetes. So that is how the overall deployment would look like for our demo. Now, if we just quickly talk about the stateful set, so what would happen in Kubernetes? There is no guarantee when it comes to the pod. Okay, so when we run a deployment or any service, what would happen? It may run n number of pods. And it is also possible, because the pods are ephemeral, so it is also possible that a pod will crash. In that case, depending on the desired state configured, Kubernetes may decide to run a replacement pod. So you can see the pods can change at any point of time. So let's say if there is a client who wants to interact with the pods, then how does it know which pod should I connect to? Because, for example, there is a client which is talking to this pod or maybe this pod, but after some time, let's say this pod crashes and there is a replacement pod, and this pod would have a different IP. So how does the client know that I need to connect to this pod? So to solve this problem, Kubernetes provides the abstraction of Kubernetes services. So what would happen? You create a service, and the service is linked to different pods of your deployment, and the client talks to the service. So in this way, even if there is a change in the underlying pods, the service is fixed, so there is no impact on the client. Now, when it comes to the stateful set, there are additional guarantees related to pods. So for example, in case of a stateful set, pods are given a definite name, and in case there is a replacement pod, it will have the same name. So for example, the name of this pod is P0, P1 and P2, and after some time, let's say P0 crashes, there is a replacement pod, this is a new pod, but it will have the same name P0. The another one would be, say for example, there are n number of pods. So with stateful set, it is possible to achieve this behavior where the Kubernetes will first create this pod P0. Once the P0 is up and running, then it will create or run another pod, then it will create another pod. So you can see there is some level of deterministic behavior when it comes to stateful set. So because databases needs to persist the data, that is why we are creating a stateful set for the database. Okay, now that we understand the overall landscape of this demo, let's start by creating the image for the application, and we know how to do that. Let's go back to the IntelliJ. So we are back to the IntelliJ, and in order to create the container image for this application, we will use the Spring Boot image plugin that we covered in the last video. How do we run that plugin? If we go to the Maven section in the IntelliJ and expand this, there is the section of plugins, and under Spring Boot, this is the plugin that we are going to use. And to configure this, we can always configure this using modify run configuration that I have already done. Same as last video, I have already configured the runtime configuration. So if we check this out, you can see that this is the name of the image. This is the version. This is my username so that it can publish to my Docker Hub registry. And this is the flag which is set to true. That means we are asking the plugin to generate the image and publish it to my Docker Hub registry. So you can provide both the arguments, and then if you run this plugin, it should generate the container image for your application. So let's do that. Now when we run this plugin, it will take some time to create the Docker image of your application. So we can see that the plugin has created and published the image. We can verify this. I can do the same thing from my Docker desktop since I'm logged in. So if I go to images section and to my hub, then here we can see this is the image that we just created. Okay. Now, before you run this plugin, please make sure that you are logged in on your local system. There is a Docker daemon running so that it can actually create the image and publish to your Docker Hub registry. Alright, so we have completed the step 1, that is to have the application container image. The next step is we will move on to the Kubernetes part. So we will walk through the configs, which is the YAML config, and we will see how to deploy the objects and how to test the application. Okay, so to do that, first of all, we need to have the Kubernetes up and running. And since I'm using Docker desktop, my Kubernetes is up and running. And in the same way, please make sure that you are running Kubernetes on your local system. Let's check out the Kubernetes objects, the configs. So the first thing is we need to create the namespace so that we can group all the resources for this demo under the same namespace. So this is the config file that will tell Kubernetes that we want to create a namespace, and the name of that namespace is this one. The second config is to create the secret, Kubernetes secret, and same as the last video, we are putting this secret in this namespace that we created. And in this secret, there are two properties, Postgres user and Postgres password, because we need to pass these two values when we run the Postgres. And in the same way, if there are other sensitive properties, you can put them in Kubernetes secret or maybe in some kind of vault, because we don't want to hard code these things in the image or in the code. Okay. Then the next step is we need to initialize the init script. So if you remember, we have to initialize the data while running the Postgres container, and for that we were using init.sql when we ran the Docker container on the local system. In the same way, when we run the Postgres database in Kubernetes, we need to initialize the database. So somehow we need to inject the same init.sql to the Kubernetes cluster. And to do that, we will use the config map, which is same as the secrets but less sensitive. So to feed some data, to inject some data, which is, for example, some properties or the content of files like init.sql, we can use the config map. Now in this demo, what we will do, we will actually use this way. So all the Kubernetes objects that we are creating using YAML file, we can also create them using command line. So here we will run the command to create the config map. And what we are doing, we are passing the namespace that we created. Then we are telling the Kubernetes that we want to create a config map. The name of that config map is going to be this one. And we are telling Kubernetes that from this directory where I have kept my init.sql, please read the init.sql file, and whatever content you found in this directory, in this file, create a config map out of this. Now, additionally, we are telling Kubernetes that do not create this config map just now. Instead, this is a dry run. Then we are redirecting the output to this file within the same directory where we have kept all the YAML files. Okay, and we are giving it a name. So what Kubernetes will do, it will read the init.sql file from this directory. It will create a config map. But instead of actually creating it, the respective YAML configuration will be dumped in this file that we can run later. So any resource that we create using commands, we can actually use the dry run command to redirect the output to a file that we can run later. So that YAML code is actually the actual blueprint of the object that we are trying to create in Kubernetes. So in this case, this is going to be config map. So once we run the command, we will have the config map YAML. And once we have that, we can move on to the Postgres stateful set YAML, which has the configuration to tell Kubernetes how to run Postgres. Now you can see first we are creating a service as we discussed. First, we are creating the service. The name of that service is going to be this one, and it is in the same namespace that we created. Then we are configuring that this service will expose the port 5432, which is the usual Postgres port, so that the application can connect to or talk to this Postgres service. The name of this port is going to be Postgres. We can change this one. This is just that a port is kind of a resource within this configuration, and we are naming that resource. We can in fact change this one to, let's say, port. This is just the naming of that resource. Then we can see the cluster IP is none. This is called a headless service because this has no use outside the cluster. Only application will be talking to this service. Then how does this select the pods? That's where we provide the selector. So it will see that any pod that has this label will be linked to this service. So that brings us to the stateful set configuration within the same YAML file. So here we are creating a stateful set, and name of this set is Postgres STS within the same namespace, and it is using the service Postgres service. Okay, this is the same service that we created here, and the pods that it will create for Postgres, they will have this label Postgres-DB. Okay. And this is where we are providing the information related to the Postgres image. So this is the container that will be run by the pod. This is the image that we are going to use. This is the same image that we used when we ran the Docker container on the local system. Image pull policy, that if you don't find the image, pull it from the Docker Hub registry in this case. Okay. And this is the port exposed by this container 5432, name, again the same name. And then we are passing the environment variables Postgres user and Postgres password. And you can see that we are telling Kubernetes to fetch the value of this environment variable from the secret that we created here. Okay, from the secret, the name of this secret was db-secret. So you can see that we are telling that you need to fetch this environment variable from this secret, and the name of this secret is db-secret, and the key is Postgres-user, which is this one. And this will be injected, this value will be injected. And in the same way for the Postgres password, we are again reading from the db-secret, which is the Kubernetes secret, and basically this key. Then we are also passing another variable, and in this case you can see this is hard-coded, the name of the database, and ideally we would also put this variable somewhere, maybe a config map or in the same secret. Then you can see this is the readiness probe that Kubernetes will use to test whether the service is up and running. And this is the configuration related to readiness probe. Maybe we will cover it later in one of the future videos. As for the volume mounts, we know that we need to mount the volume. So this is the name of the volume, and this is the directory inside the Docker container. Then the second mount is init-SQL. This is to mount or to bind the init.sql property to this particular part that we already covered. And this is where we define init-SQL. We are telling that you need to read init.sql from this config map. So you can see this is the name of the config map. And if we remember the command, this is the same name that we gave to the config map when we created it using the command. Okay, so that's how we are instructing Kubernetes where to read the data from. Then in the end, we see volume claim template. So this is related to the Kubernetes or the pod storage. We don't need to focus on this one as of now. The important thing is how we configure the image to run it as a Postgres service. The last bit is the application config that will tell Kubernetes how to run the application that we have created. So here again, we have this service, and this is the name of the service. This is the namespace. And in this case, we can see that this is a cluster IP service. That means it will be accessible only from the Kubernetes cluster. And that is why we need to use the port forward to access it. Okay. And these are the ports that we are exposing using this service. Coming to the deployment section, this is the deployment that will actually create the pods. So you can see this is the label that will be given to pods, which will be started by Kubernetes as part of this deployment. Coming to the image, this is the image that we created. We need to specify it here so that Kubernetes can find the image and run the application. This is the name of the image and the tag and my username, because in this case we are storing the image in my Docker Hub registry. And then here you can see that we are overriding the database URL, username and password. So for a second, if we go back to the IntelliJ, we can see that we are actually using these variables, and the default values are for local development. So in case we provide some other value, we can override them using these variables. And that's what we are doing here. So for the database URL, we are passing this value. And if you notice here, we are not passing any IP like localhost. Instead, we are passing a service name. So this is the same service that we created, that we provided here in this stateful set YAML configuration for Postgres. And this is the service that we are creating for Postgres. Since both of them are executed by the Kubernetes, so Kubernetes knows that how to find the Postgres which is being referred here by the service name. And this is the benefit of service discovery within the Kubernetes. So in this case, we don't need to provide the IP or anything like that. We can use the service name. Port, of course, is going to be 5432, and this is the database. And you can see this part is hard-coded. We can even make it configurable. For the database username, we are again reading this property from the secret that we created. So you can see db-secret, and this is the key Postgres user, in the same way password. And then we have the readiness probe and liveness probe. And these are the URL endpoints that will be exposed in the application because we are using actuator. So that's it on the app.yaml. Now that we understand all the configs, this is the time when we run the commands, when we apply those YAMLs, and we actually create the Kubernetes resources and we test the application. So since the Kubernetes is already up and running on my system, I can use any terminal to interact with it. And for the ease of use, I will use my terminal, which is available here in the VS Code itself. So let's first verify if we can connect to the Kubernetes. So we can see no resources found in default namespace. That means we can connect to the Kubernetes using kubectl. So first of all, we need to set some variables. This is the variable for the namespace so that we don't have to type it. And this is the directory where I have kept all the YAML configuration. So if I just show you, this is the directory on my local where I have kept all the YAML files. Okay, then first of all, we will create the namespace. And we know how to do that. We use kubectl command apply to apply the changes, and -f, that is how we provide the file that we are going to apply. So in this case, the first one is going to be the namespace config. And we can see that the namespace has been created. We can verify it if we just read all the namespaces. Then we can see this namespace is in the list now. Okay. The second step is to create the secrets. This is also created. The next step is to create the config map YAML file for the init.sql. So we will run this command, and in the same directory, we should have this 02 file now. So if we check this out, we can see this is the file that has been created by using this command, and you can check out the content as well. So this is something that Kubernetes has created as a result of this command. Okay. And the same data will be injected to the Kubernetes deployment. All right. So this step has only created the config map YAML file for this config map, but it has not created that config map for the init.sql. To do that, we need to run the same command kubectl apply and then -f and the name of this file. And now we can see that this config map has been created. Okay. Then we will run the Postgres database. To do that, we need to apply the Postgres YAML configuration. And you can see this is creating the Postgres service as well as the stateful set. Now we can check out the status of this rollout because it will take a couple of seconds to actually run the pods for Postgres. So you can see waiting for one pods to be ready. And we can also check the same status from the Docker desktop. So if we select the namespace that we created, so we can see the pod is pending right now. Service is also as of now none. And this is the same service that has been created for the Postgres. And you can see all the secrets that we created. So this is the secret. This is the config map for the init.sql. So this is still pending. It will take a couple of seconds to download the Postgres image from the internet and then to run the pod to basically run the container for Postgres. So let's give it some time. So we can see that the Postgres stateful set is now completed. The rollout has been completed. So if we check the pods, then we can see that there is a pod running for Postgres. Then to verify if the init.sql thing worked, we need to run this exec command. Okay. So we are trying to enter the Postgres container and then we are asking it to run the bash. So if we do that, we will have access to the Docker container. This is the database like this. And if we check the table, then we can see this data. So that means the database thing worked perfectly fine. Let's exit out of this container, and the last thing that we will do is we will deploy the application. And then in the same way, we will check the rollout status of the application. So we can see that the service has been created and the deployment has been created, but we need to see if this has been rolled out. So we can see that the waiting for deployment rollout to finish, and we can see the same thing on the Docker desktop. So here we can see that this deployment is actually in progress as of now, and the underlying pods for the service. So let's wait for this rollout to finish. And this will take some time because it needs to download the image of the application that we created from the Docker Hub registry. So we can see that the application deployment is also successful, and if we run to check the pods, we can see there is one pod running for Postgres and the other pod is running for the application deployment. And all of them are running a single pod, a single replica, so everything is up and running. Now, in order to test the application, we know that we need to run this port forward command to basically bind the port from the local system to the Kubernetes service. So if we run this command, then it will do the binding thing for the port, and we can check the application now. If we just hit the events endpoint again, localhost :8080, then it should talk to the service which is running on the Kubernetes, and we can see we can access the data. That means the application as well as the Postgres has been successfully deployed on the Kubernetes, and we can access the application. The application in turn is talking to the database, fetching the data from the database. So that's all for this video. In this video, we created the Spring Boot application with the database connectivity. Then we ran the database in a Docker container, and in the end, we deployed everything on the Kubernetes. So in this case, there are two sets. The first one is the stateful set, which is running the Postgres. And the second one is the service or the underlying deployments for the application. So that's how we configure and deploy the application as well as the database on the Kubernetes cluster. So that's all for this video. I will see you in the next one with more stuff on Spring Boot and Kubernetes. Thanks for watching.